You know, some problems in number theory just have this incredible classical elegance.
Oh, absolutely.
Like the question of how many ways you can write a number, let's say n, as a sum of k squares.
Right. And for four squares, for
Yeah.
k equals 4, the answer is just, well, it's pure mathematical poetry.
It really is.
Jacobi's formula for it, for
Mhm.
R4 of n, it's exact, it's clean. It's just 8 times the sum of the divisors of n. Simple, predictable arithmetic.
But that's the thing, you add just one more square.
Yeah.
You go to 5 squares.
Mm-hmm.
And the whole beautiful structure just, it seems to collapse. Why? Why does that fifth square, an odd dimension, break everything?
Well, it's because the entire underlying geometry changes. The problem for four squares connects to these uh, really well-behaved mathematical objects.
Okay.
But for five squares, you're in a different world. You're dealing with what we call half-integral weight forms. And that means, simply put, you can't get an exact answer using those simple arithmetic functions anymore.
So the answer is tied up in something much deeper.
Much deeper. Things like class numbers and quadratic fields, the complexity just explodes.
So if we can't get that perfect exact answer, we have to look for the next best thing, a powerful approximation.
Exactly.
And this is where Emil Grosswald comes in. Our mission today is to really unpack his breakthrough, the Grosswald asymptotic formula for 5 squares.
And what's so fascinating is how he got there.
Yeah.
Usually for this kind of problem, you'd have to pull out the heavy analytical machinery, the Hardy-Littlewood circle method.
That sounds intense.
It is. It involves complex integration.
Yeah.
It's really high-level stuff.
And finding that right tool, that perfect method to connect the known world of 4 squares to the unknown of 5 squares, that takes some pretty cutting-edge thinking.
It really does.
It's a good reminder that if you're facing your own complex integration or system challenges, finding that right approach is everything.
And speaking of the right tools, this deep dive is supported by Embersilk.
That's right.
If you need help with complex problem solving, like AI training, automation, or software development, you should check out embersilk.com. They're experts at finding where AI agents can make the biggest impact. That's embersilk.com.
Okay, so back to the numbers. Let's talk about Grosswald's brilliant move.
Yeah.
He connects R5 of n directly back to R4 of n. Summation, right? You sum up all the ways to make n minus some square, j squared.
That's the one. And Grosswald, working with the Callaways, had this amazing realization.
What was that?
Since we have that perfect exact formula from Jacobi for 4 squares,
The one we started with.
right, you can just plug it into that summation.
Yeah.
And then you can work out the approximation using just, elementary arguments, no heavy machinery needed.
So he bypassed the circle method entirely.
He did. The breakthrough wasn't just the formula itself, but proving you could get to this high-level result using fundamental number theory. It was a conceptual leap.
That's fantastic. So, okay, does getting an approximation mean we've sort of given up on finding an exact formula for 5 squares?
Oh, not at all. It means we understand the boundaries better. And this approximation for large n is incredibly accurate. The main part of it, the main term, is a constant times n to the 3/2 power, times something called a Dirichlet L series.
Which is a way of encoding information about primes.
It's a great way to think about it. It's a very sophisticated tool, yes.
And the formula even tells us what the error looks like, this cusp form.
Exactly. And that cusp-form isn't just random noise. It's a real mathematical object that represents the irreducible complexity of the problem, the part you can't describe with the simpler main term.
So even the error has structure.
It has deep structure. So the approximation gives us profound insight, even without being perfectly exact.
It really is a fantastic lesson in what progress looks like. When mathematics closes one door on perfect simplicity, human ingenuity just finds another way to chart the territory.
That's it, exactly.
The most powerful truth here isn't a simple answer, but a nearly perfect understanding of a deep and complex structure. What an amazing idea to end on. If you enjoyed this deep dive into the fascinating world of analytic number theory, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.